Which message broker would you use? It's one of the most common system design questions there is, and there's a right way and a wrong way to answer it. The wrong way is to blurt out, Kafka, because it's the one you know. The right way is a structured answer that shows you actually understand the trade-offs. So let me give you that structure, a framework you can apply to any scenario they throw at you. Here's the order to think in. First, the model, log or queue. Second, throughput. Third, operational burden. Lead with the model, always, because that's the decision that drives everything else. Let me give you the framework in 3 buckets. Reach for a log, that's Kafka, Kinesis, Event Hubs, Pulsar, when you need replay, when multiple independent teams read the same events, when you're doing event sourcing or change data capture, or when you need real-time stream processing. The key word that should trigger log in your head is replay, or the phrase many independent consumers. Reach for a queue. That's RabbitMQ or Azure Service Bus, when you're distributing tasks across competing workers, when you need complex routing or filtering, when you need per message priority or expiry or request reply, and when the volume is moderate, so a full streaming platform would be overkill. The keyword here is routing or task queue. And reach for a managed cloud service, the simple queue service with the notification service, or Google PubSub, when you want 0 operations, when your consumers are serverless and scale from 0, and when you just need simple decoupling and fan out without running a cluster. The keyword is 0 ops, or serverless. Now let me give you the head-to-head everyone wants. Kafka versus RabbitMQ. This is worth being able to rattle off. Philosophy. Kafka is a dumb broker with a smart consumer. RabbitMQ is a smart broker with a dumb consumer. What happens to data after it's read? In Kafka, it's retained and replayable. In RabbitMQ, it's deleted after acknowledgement. How many consumers can read the same data? In Kafka, many independent groups. In RabbitMQ, essentially 1, unless you fan out to a queue per consumer. Routing? Kafka pushes that to the consumer. RabbitMQ has rich exchange-based routing built in. And what's each one best at? Kafka, throughput, replay, streaming. RabbitMQ, routing, priority, request reply, and task queues. Here's the one-liner to memorize. RabbitMQ routes and manages per message state for me, great for task queues and complex routing. Kafka is a durable log, great when I need replay, huge throughput, or many independent consumers. And if I need both, I use them together. That last part is the pro move, so let me expand on it, the hybrid pattern. Mature systems at scale often use both, and here's the shape. You use a log, Kafka, for the high fan-out analytical layer, the part where lots of consumers need the same high-volume event stream with replay. Analytics reads it, a search indexer reads it, an enrichment service reads it. And then, for the one critical step that must happen exactly once and in order, the actual side-effecting execution, you feed into a queue with a single consumer group. Log for the fan-out, queue for the careful execution. A couple of cross-cloud notes that make you sound current. Azure Event Hubs exposes a Kafka-compatible endpoint, so your Kafka clients work unchanged. It's a great middle ground on Azure, though it lacks the full Kafka ecosystem. And Red Panda is Kafka API compatible, but with no JVM and no Zookeeper, a single binary with lower latency. It's a drop-in for teams who want Kafka's semantics with much simpler operations. Notice what we did in this whole episode. We never just named a product. We reasoned from requirements, replay, routing, throughput, operations, to a model, and from the model to a broker. Do that, and you'll never be caught flat-footed by which broker would you use, no matter what constraints they add. That wraps our broker tour. Starting next episode, we shift from what to use to how to use it well, the production patterns that keep real systems alive. First up, reliability, and how to survive failure. See